Inside millions of old measurements, an answer has been waiting. Astronomers stared at these same numbers for years and saw nothing. Then, a machine looked at those files in a brand new way. Not one hidden planet, 301. If you love stories like this, real science without the hype, hit subscribe. Every week we dig into the biggest space discoveries and tell you exactly what they mean, plain and simple. One tap and you never miss the next secret. That number did not come from a brand new telescope pointed at fresh parts of the sky. It came from old data gathered years ago by a spacecraft that went quiet long ago. Data that scientists had already gone through, checked, and mostly set aside. Then, in 2021, a team at NASA's Ames Research Center in California handed it all to a computer program that learns patterns on its own. In a short time, that program pulled 301 new planets out of the pile. Planets hiding in plain sight the whole time. To understand why that matters so much, you have to go back to the beginning. You have to meet a telescope named Kepler. For most of human history, the planets we knew were the ones next door: Mercury, Venus, Mars, Jupiter, Saturn, and the rest, all circling our own sun. Beyond them, nothing, a blank. Scientists guessed at what might live around other stars, but a guess is not a fact, and nobody had any facts at all. Then, in 1995, two scientists named Michel Mayor and Didier Queloz found the first planet circling a star like our Sun. They did not see it with their eyes. They saw the star wobble, pulled by something heavy passing nearby. That world, called 51 Pegasi b, opened a door that had been locked for centuries. Suddenly, other worlds were real. Here is a strange twist that most people never hear. The very first planets ever confirmed outside our solar system were not found around a sun-like star at all. A scientist named Alexander Volstyan found them in 1992, circling the crushed corpse of an exploded star, something called a pulsar. Worlds circling a dead star. It sounded impossible. It was true, and it proved that the universe could surprise us in ways nobody had imagined. But finding planets one wobble at a time is painfully slow, and you need a way to scan many stars at once. That is exactly what Kepler was built to do. Scientists call worlds around other stars exoplanets because they live outside our solar system. Kepler launched in March of 2009 with one job: find other worlds. It stared at one slice of sky. Inside that slice sat more than 150,000 stars, packed together like a crowded city at night. And Kepler did not blink. It watched those stars for years, taking picture after picture, measuring the light from every single one of them, again and again. The idea behind it was simple.
When a planet passes in front of its star, the star's light dips a tiny bit, like a hand passing in front of a lamp. The light dims for a moment, then comes back. Measure that dip, and you have found a planet. Scientists call this the transit method. Here is how tiny that dip really is. A giant planet like Jupiter blocks about 1% of its star's light when it crosses. 1% sounds small, but it is huge compared to what comes next. A planet the size of Earth blocks only about 1 part in 10,000. Imagine a lamp shining in a dark field and a mosquito flying in front of it. That wisp of shadow is what astronomers are chasing. It sounds easy when you say it out loud. The truth is brutally hard. The dip in the light is almost nothing. A human eye staring at raw numbers would never spot it. And on top of that, the data is drowning in noise. The spacecraft shakes. The camera heats up and cools down. Dust drifts through the light. 1,000 tiny annoyances can make a star look like it is flickering when nothing is there at all. So every single blip in the data has to be tested. Is this a planet? Is this just the camera? Is this a pair of stars playing tricks on us? Each question takes time, and time is the one thing scientists never have enough of. Kepler's original mission was supposed to last about 3.5 years, and it would have been a success even if it had stopped right there. It had already flagged thousands of planet candidates. Then, in 2013, something broke. Two of the wheels that kept Kepler pointed at the stars stopped spinning. Without them, Kepler could not hold still, and a shaking telescope cannot measure a tiny dip in starlight. Everyone thought the mission was over. Engineers refused to give up. They used the gentle pressure of sunlight to balance the telescope, the way a sailboat leans into the wind, and Kepler lived again. The new phase was called K2, and it kept finding planets for years. When the mission finally ended in 2018, after almost a decade of work, Kepler had flagged more than 9,000 possible planets. Scientists were left with a mountain of data, and buried somewhere inside that mountain were the faint fingerprints of planets. And here was the painful part. A computer could flag a possible planet in seconds, but figuring out which flags were real worlds and which ones were just noise took an enormous amount of human time. One scientist could check only so many signals in a day, in a week, in a whole year. The mountain never shrank, it only grew. So the data piled up, and the pile slowly started to feel like a wall. Most scientists assumed the best finds had already been made. The easy planets had been found, checked, and written up in exciting papers. The leftovers looked like junk. Thousands of leftover signals sat in a public archive called the Kepler archive, waiting for someone to look at them. Some of those signals had been sitting there for many years. Nobody had the time to check all of them. Many people quietly believed the leftovers were mostly false alarms, little more than noise with a fancy file name. But nobody had actually checked them all. There were too many. Too many signals, too little time, too few people. So the files just sat there, like a library with thousands of unopened books on the shelves. Here is the part that makes this story even stranger. That archive is not locked away in some secret vault. It belongs to everyone. The data is public and free, so any person on Earth can download it and study it. For years, the planet sat in a room with the door wide open, and almost nobody walked in. The ones who finally did were not a giant team with a giant budget. They were a small group with a clever machine. Now here's the detail people remember most. Those leftover files were not junk. They were full of planets. The universe had put them there for us to find. The only thing missing was a set of eyes fast enough and careful enough to actually see them. In 2021, those eyes finally arrived. Did you know that a single unopened file from an old telescope could hide hundreds of planets? Most people have no idea the old data still holds secrets like this. If that surprises you, drop a comment telling us what you think is still hiding in the archive, and hit like so this story reaches more curious people like you. Here is how that moment looked from the inside. At NASA's Ames Research Center, a team led by a researcher named Hamed Valizadegan had spent a long time building a special kind of program. They called it ExoMiner. The name sounds like a character from a video game, but ExoMiner is really just a brain made of numbers, trained to do one thing better than any human ever could: spot the tiny sign of a planet inside a river of noisy data. The team fed ExoMiner thousands of examples of real planets. They also fed it thousands of examples of fake ones. Most of the fakes were pairs of stars called eclipsing binaries, two stars circling each other so that one regularly passes in front of the other, making the light dip exactly like a planet would. Telling them apart takes real skill, the kind of skill built over years of squinting at graphs. Then the team told the machine to learn the difference on its own. Learning inside a computer means adjusting millions of tiny dials over and over until the answers come out right. By the time ExoMiner finished learning, it had become the sharpest planet hunter in the world. Then they let it loose on the leftovers, the old, dusty files in the Kepler archive that no human had ever fully checked. ExoMiner crawled through the pile with the patience only a machine can have. It did not get tired. It did not get bored. It did not get sloppy near the end of the day. And it came back with an answer that made the whole astronomy world sit up. 301 of those old leftover signals were real planets, not guesses, not maybes, planets spinning around their stars exactly the way Earth spins around the sun. The team at NASA Ames counted carefully. Before ExoMiner, the official list of validated planets stood at about 4,569. Add the 301 new finds, and the list jumps past 4,870. The machines were not just finding stray planets, they were reshaping the map of the galaxy. Here is what the machine also taught scientists about their own habits. Every leftover file had already passed through the Kepler pipeline, a set of tools built by humans. Something in that pipeline had flagged each file as a possible planet. Something had saved it instead of deleting it. Yet nobody could say for sure whether it was real.
So those files waited for years in a digital closet that nobody had time to clean out.
The team wrote up the discovery in the Astrophysical Journal, one of the most respected science journals in the world. And here is what makes this even better. A lot of smart computer programs in science are what people call black boxes. They give you an answer, but nobody can explain how they got it. ExoMiner is different. A scientist named John Jenkins said it plainly. We can easily explain which features in the data lead ExoMiner to reject or confirm a planet. That means every one of those 301 discoveries can be checked, tested, and trusted. Hamed Valizadegan put it even more sharply. When ExoMiner says something is a planet, you can be sure it is a planet. Think about what that sentence really means. The machine became more trusted than the people who built it. Valizadegan admitted this out loud. He said the program is in some ways more reliable than the human experts it was meant to copy, because people bring biases with them. Bias, in plain words, means a silent tug in one direction. A person who has looked at 10,000 signals starts to feel tired. A person who has been fooled before starts to expect the worst. The machine has none of those feelings. It judges every single signal the same way, from the first file to the last. And that consistency is the whole difference between missing 301 planets and finding them. So here is a question for you. If a machine can be more reliable than the experts who built it, what does that mean for every other field where people were certain they had already found everything? Doctors reading scans, engineers reading sensor data, all of us reading the world around us. Tell us what you think in the comments and drop a like if this story is giving you goosebumps, because we are just getting started. And here's the part that should give you actual goosebumps. Kepler is not the only telescope with hidden treasures. Scientists had noticed for a long time that something else kept sending strange signals to Earth, something far away, something powerful, something that refused to behave like anything we understood. It started in 2007 with a discovery made almost by accident. A scientist named Duncan Lorimer was digging through old telescope files when he found a flash that had been sitting there for years. Nobody had noticed it because nobody knew what to look for. It was a burst of radio energy so bright and so fast that it blinked in and out in a few thousandths of a second. Astronomers named this whole family of mysteries fast radio bursts. To put that power in human terms, imagine every power plant in a busy city pouring all of its energy into a single camera flash, faster than you can blink. That is the kind of concentrated punch we are talking about. And the signal crossed billions of light years of space before it hit our antennas. In 2012, they caught one that was special. It kept repeating. Over and over, the same source sent new pulses, like a lighthouse spinning in the dark. They gave it a catalog name, FRB121102, and learned it lives about 3 billion light-years from Earth. 3 billion light-years. That is so far that the light we see left that place before life on Earth even got complicated. Astronomers were fascinated and a little bit creeped out. Nobody knew what was doing it. Some ideas sounded like science fiction. A dead star with a crushing magnetic field, gas blasted by a black hole. A few scientists very quietly even wondered if some advanced civilization was sending the pulses on purpose. In 2017, a team from a project called Breakthrough Listen, based at the University of California, Berkeley, aimed one of the biggest ears on Earth at the source. That ear is the Green Bank Telescope in West Virginia, a dish so large you could park a herd of elephants on it and still have room to spare. On August 26th, over 5 hours, it recorded 400 terabytes of data. 400 terabytes is enough to hold the text of every book ever written, many times over. Ordinary computer programs, the best the scientists had, combed through that mountain and found 21 bursts. All of them arrived within a single hour, as if the source stayed quiet for most of the night and then suddenly woke up. 21 bursts. That seemed like a decent haul. The team wrote it up and moved on. They were wrong, and the machine would prove it. A doctoral student at Berkeley named Jerry Zhang built a new kind of artificial intelligence, a program inspired by how the human brain recognizes images. He trained it to recognize the bursts the old method had already found. Then he pointed the same machine back at the exact same data and let it work. The old method found 21 bursts. The machine found 72 more. Bursts that had been hiding inside the data the whole time, invisible to every human tool. In one afternoon of computing, the machine did better than a whole team had done in months. That brought the total bursts known from that one source to around 300 since 2012. The new signals did more than raise the count. They changed what scientists could say about the source. Before the machine's work, all 21 bursts had arrived inside a single hour, which made the source look like a faucet that switches on and off. The extra bursts told a different story. The pulses do not march to a regular clock. The source is erratic, unpredictable, and stranger than the tidy picture scientists had painted. Here is a question for you, and I want you to think about this one. If a machine can find 72 hidden signals in data that scientists already searched, how many secrets are still hiding in all the other old files? Tell us your wildest guess in the comments below, and if you want to follow along as more of these secrets get unlocked, join the channel. We will be here for every single one. That question is not just a fun thought experiment, it is happening in real time, right now. NASA has confirmed more than 6,000 planets outside our solar system. More than 6,000 worlds that nobody even knew existed 50 years ago, and more than half of those planets came from just 2 missions, Kepler and TESS, a newer satellite still scanning the sky today. TESS started work in 2018, and it has been pointed at nearly the whole sky ever since. In its first 2 years alone, TESS mapped about 3/4 of the whole sky. That is a map of the heavens so wide that Kepler, locked on its tiny patch of stars, would have needed centuries to trace it all. And every one of those stars was measured again and again, which means the secrets are not just hidden, they are buried under an ocean of numbers. So the same story started playing out again, only bigger. TESS flagged thousands of possible planets. Astronomers dug through them as fast as they could. The pile grew faster than the people, and once again, the machine stepped in. Scientists at the University of Warwick in England built a system called Raven, named after the smart black bird. Raven does the whole job by itself. It catches the dip in the light, tests it with artificial intelligence, and decides whether it is really a planet. The team trained Raven on hundreds of thousands of computer-made planets, worlds with every possible size, orbit, and position. To build that training set, the Warwick team made hundreds of thousands of fake worlds and fake imposters, computer simulations of everything that could masquerade as a planet, right down to the noise of the camera itself. An AI is only as good as its examples, and Raven was given every trick in the book. When it finally met real data, it refused to be fooled by the old disguises that had tricked humans for years. Then they let it dig through test data, and in 2026 they announced the results. Raven validated more than 100 planets, including 31 brand new worlds that no human had ever seen before. And it did not stop there. It flagged more than 2,000 new planet candidates, nearly 1,000 of them entirely unknown, waiting for proof. Listen to what the machine found inside that pile, because some of those worlds should not exist. There were ultra-short period planets, worlds that whip all the way around their star in less than a single day. A whole year on one of those planets takes less time than one trip to school and back. There were also planets sitting in a region astronomers call the Neptunian Desert. Neptunian because the worlds there are about the size of Neptune. Desert because almost none are supposed to live there. Theories said that any planet that close to its star, that size, would have been worn away long ago. The desert was supposed to be empty. The machine found planets living in it anyway. But the machine gave scientists something else, a number they could use and trust. Planets in that desert are incredibly rare, appearing around just 0.08% of Sun-like stars. Almost none exist, and now the world knows exactly how close to none. For the first time ever, scientists could measure the emptiness of the desert instead of just guessing at it. That is the difference between saying something is rare and proving how rare it is. Hear the same pattern from the other side. Studies show that about 9 or 10% of Sun-like stars host a planet orbiting very close in. Roughly 1 star in 10 has a close neighbor world. Imagine a street with 10 houses, and one of them hiding a secret planet in its backyard. Now multiply that street across the entire galaxy, and you start to feel the scale of what the machines are finding. Does this pattern sound familiar? It should. First Kepler, then the radio bursts, now TESS. Every time scientists think they have reached the bottom of the data, a machine digs one layer deeper and finds something new. This is not luck. This is not a fluke. This is what happens when a patient, tireless mind meets a mountain of old information. Because now the machines are finding things that are not planets at all. In 2025, a team at the Max Planck Institute for the Science of Light turned a different kind of artificial intelligence loose on a very different problem. They asked the machine to design a better gravitational wave detector. A gravitational wave is a ripple in the fabric of space itself, caused by two enormous things smashing into each other, like two black holes colliding far across the universe. When the ripple passes through Earth, it stretches and squeezes everything around us by less than the width of an atom. Detecting it is one of the hardest measurement jobs humans have ever attempted. Scientists had tinkered with the design for years, carefully, by hand, one small improvement at a time. The machine did not tinker. It looked at the whole design and asked a different question. What if the old way was not the only way? The scientists themselves said it out loud. We asked ourselves what humans overlooked in comparison to the machine, and the machine answered with a new design, a different way of arranging mirrors and lasers that the humans had never even considered. Not because they were lazy. Their eyes were trained to see the old way, while the machine had no training, no habits, no favorites. It simply found a better path that had been there all along. And that is the deep truth hiding inside every one of these stories. The machines are not smarter than scientists. They are not replacing scientists. What they are doing is more subtle and more powerful. They are seeing without bias. Every human who looks at data carries a lifetime of experience, and that experience carries invisible rules. This looks like noise. We have seen this before. Nothing new here. The machine carries none of those rules. It looks at every signal as if it is seeing it for the first time, because it is. And sometimes, that is exactly what it takes to finally see what was in front of us the entire time. Now follow this to the place where it touches your own life, because it is not as far away as it sounds. Think about the last time you looked at something old and familiar and completely missed what was right in front of you. A photo you had seen 100 times, and then one day you noticed a detail you had never spotted before. A song you had played 1,000 times, and suddenly you heard a sound hiding underneath it all. That is what happened to astronomy, but on a scale so large it is hard to wrap your mind around. Decades of data, thousands of planets, hundreds of hidden signals. All of it missed, not because the answers were secret, but because the people looking were looking the way people always look. And that brings me to a personal question. Have you ever been completely sure of something, so sure you stopped looking and then found out you were wrong? A belief about yourself, a decision you made without a second thought. That moment when the truth arrives is shocking and a little embarrassing, and also kind of wonderful. If that feeling means something to you, tell us about your moment in the comments. Tell us about a time you were sure and you were wrong. We read every single comment, and the best stories get shared with the whole community. And while you are down there, give this video a thumbs up, because your support helps more people feel that same jolt of surprise. The astronomers who run these searches will tell you something surprising. They do not feel replaced. They feel freed. The machines eat the boring hours, the checking, the sorting, the counting, and leave the humans with the best part of science, the asking. Ask what a strange new world smells like. Ask whether a pulsing signal could be a voice. The machine finds the pattern. The person names the wonder. But here is one more thing the machines cannot do. They cannot wonder. They can find a pattern, but they cannot ask why the pattern exists. That job still belongs to us. A machine can flag 7,000 candidates, but it takes a human to look at one strange world and ask what it would feel like to stand there, to look up at its sky. The machines hand us the keys. We are the ones who choose which doors to open. Now let us talk about the present, because the past is only half the story. Today, this very week, machines are working through data that no human has ever fully seen. TESS is still up there, still scanning, still sending home rivers of fresh numbers every single day. NASA has already released a new, stronger version of ExoMiner called ExoMiner++. The first run flagged 7,000 potential planets in TESS data, and the software is free for anyone in the world to download, not just NASA scientists. Anyone. A high school student in Ohio could download it tonight. A retired engineer in Japan could run it this weekend. A curious kid in Brazil could find the next planet by accident, just by exploring. Open science is the quiet engine behind all of this. NASA shares its data, and now it shares its software too. The newest ExoMiner lives on a public code site where anyone can grab it for free. NASA says that is the whole point. When researchers freely share their tools, other people can repeat the results and dig deeper. One good tool, shared with the whole planet, can move science faster than a dozen labs working in secret. The tools that used to belong only to big institutions now belong to all of us. That single fact is a quiet revolution. And the next chapter is already being written. NASA's Nancy Grace Roman Space Telescope is on the way, named after the woman who pushed NASA to build the Hubble when many powerful people said it was a waste of money. The Roman telescope will capture tens of thousands of planet transits, tens of thousands of tiny dips in the light of distant stars. If the machines were impressive with Kepler and TESS, imagine what they will do with a flood of brand new data from a brand new eye in the sky. The patterns they find there will probably look nothing like the patterns we expect. That is exactly the point. So here's the honest truth, and it is a strange one to sit with. The universe is not running out of secrets. We are running out of old ways to find them. The next great discovery is probably already sitting in a file somewhere, on a hard drive, in a public archive, waiting. It might be a planet. It might be a signal. It might be something we do not even have a name for yet. And when it is finally found, it will probably not be found by a person staring at numbers alone. It will be found by a machine, built by people, looking at the same data we have had all along, and finally seeing what we could not. So here's what I want you to do before you go. If this story made you look at old data differently, made you wonder what else is hiding in plain sight, then share this video with one person who loves a good mystery. Send it to the friend who always asks the questions nobody else thinks to ask. And tell us in the comments, what do you think is hiding in the data right now, waiting to be found? If you have not yet, tap subscribe and turn on the bell, because the next hidden pattern is already out there, and this is where you will hear about it first. Thank you for watching, for thinking, and for staying curious. The universe is full of secrets, and the best ones are the ones we have not found yet. See you in the next one.